Hi, this is James Page for ECOC TV. We're just outside the Market Focus Theatre at the moment, and I have with me Mark Wade from Ayar Labs. Mark, you've just been talking about how you feel a new era of optical I/O is here already. Why do you think that?
Yeah, so the reason we think that is that the SoC designers, so if you look at people designing large systems on chips for compute solutions, that could be a CPU, a GPU, an FPGA, or new accelerators that are coming on the market, such as for machine learning. They're all coming to the recognition that escaping large amounts of data in and out of their SoC is one of the largest performance limiters in the systems that they want to build. And you can look at today's solutions, which already today there are some SoCs are burning upwards of half of their power just moving data in and out of their chip. And that really eats into their power budget for how much they want to be spending on compute. So if you're spending all of your power on moving data, then you have less and less power to spend on for compute. Now, if you kind of dive into this problem, the fundamentals are in a trend that's been happening for a long time, which is that electrical signaling is not very good at signaling very fast over long distances. And for decades, there's been a trend for optical communications to kind of be moving into different distance regimes. Started with transoceanic kind of fiber lines, so really looking at hundreds, thousands of kind of kilometers of distance. And that trend is kind of making itself all the way down into the actual SoC package now, to where your distances are, let's say, centimeters to, and then in the rack, meters. So what we're encouraged by is we've kind of built a technology from the ground up to solve this problem. It's a new generation of an electronic photonic technology and set of products, really built on top of silicon photonics and kind of scalable silicon manufacturing. And we're providing these optical I/O chiplets, which we call our Terrify chiplet, into customer solutions right now. I think you're going to see a lot of exciting results coming out, starting now to the end of the year and in the next couple of years.
Great, it does sound very exciting, and the Terrify chiplet is sort of key to it all. Can you talk to us a little bit about what some of the key benefits of that chiplet are?
Yeah, so the Terrify chiplet, which again is short for Terabit Phi, its driving kind of design philosophy was we have to cram as much bandwidth in as small amount of space as possible, and combine the electronics and the photonics into a single die. So we did this by a decade ago in the kind of academic research phase of this, which really all started at MIT. We built what's called a silicon microring device. And this was known to the research community already, but people were really struggling to kind of build practical systems based on this device. But the benefits of that device are it's a very small device that you can drive very quickly, so it can run very fast and can run at high bandwidths, and it uses very small amounts of energy. So it's kind of the perfect device you want to be starting from if you're really trying to optimize bandwidth density and energy efficiency. But the breakthroughs were really figuring out how to make that device combined with electrical circuitry, so analog, very high-speed analog electrical circuitry, digital control systems and digital backends, and build all that onto a single chip in a way that's much denser than anyone has built before. So it all kind of starts with the bandwidth density, the power efficiency, and then ultimately what kind of latencies we can achieve on our links with that chip.
So there's some fantastic work going on at Ayar Labs, but I think you're quite clear that it's not something necessarily that you can do on your own, and it's quite important that there are partners and there's an ecosystem. So how important is the work of the CWWDM MSA to the further development?
Yeah, at Ayar Labs, we really kind of consider ourselves to be a fabless design company. So, we're trying to take the model that's been incredibly successful in the CMOS world, which kind of separated out design companies from manufacturing companies. And, I'd say maybe our bold claim is that we're going to be the first massively successful company to go after that same model, but with photonics and electronic photonic solutions. And so if you're going to do that, and you're not going to own your own manufacturing, then it all comes down to making the right partnerships throughout the supply chain in the right manufacturing partnerships on both the Terrify side and on our laser side, where we build our Supernova laser light source. And on the laser side, that's where we've chosen to kind of start. It's the first place that we're working on standardizing parts of the solution, writing down specifications, making those specifications public, partnering with a variety of manufacturers, both the tier 1 laser manufacturers, as well as some of the component makers throughout the supply chain. And it's incredibly important for us to go work on all of this together, because there are too many problems to solve for one company to solve it. So this is really a classic case of all ships kind of rising with a rising tide. The reason we chose to work on the laser first is because we're pursuing a remote laser architecture that separates out the laser from the Terrify. And it has a variety of economic and kind of performance benefits. But we have to look at all the physical connections between these two things, and then how people are going to build platforms and systems. So if you go look at a full system that's built, there are a large number of components that go build that system, and you need a large kind of portion of the supply chain to be aligned to a single direction. So we're excited to be kind of pushing forward in this direction and leading the effort here to work on standards for optical I/O. And the CWWDM MSA is really kind of where all the action is happening right now.
Okay. Well, thank you very much for taking the time to explain it. I think anybody who's seen your presentation here this morning will feel the excitement, and I think very much we need to watch this space. Well, thanks very much for joining us at ECOC TV.
Yeah, thank you for having me.